Okay, so we're going to continue our discussion of gases, and of course, as we've been discussing with gases, we're under pressure. So I got Freddie Mercury on the screen, Queen sang under pressure. So we're constantly under the pressure of gases pushing down on us all the time. You know, if you go up into the mountains, you can feel that the pressure changes as we change altitude, right? A lot of times athletes will train at different altitudes because you have less gas if there's less pressure and things like that. So it makes it harder to compete at the same level if you're not intaking the same amount of oxygen atoms that you're used to. So we'll talk a little bit about why pressure changes with altitude and stuff like that. But what affects pressure in the end? So I'm talking about altitude, but yeah, it's not really what we're talking about in this class. We've talked about things like temperature and pressure and volume and number of molecules and things like that. So, you know, can we change the pressure that a specific sample of gas is exerting? Like, can we change the pressure that the gas is putting out? What can cause this change? Is pressure related to anything else, or is pressure independent of everything else? I don't know. But we can sure figure all that out. So we can figure out what causes this change. We know that we're going to figure out or find out that pressure is related to some of these other properties. And yes, you can change the pressure that a specific sample of gas is exerting. So the rest of this chapter and all of these videos about the individual gas laws are going to relate that pressure difference to the pressure with all of the different factors that affect it. So Boyle's law is going to be our next law. So we've seen Dalton so far. Now we're going to see Boyle. So Boyle's law relates the ideas of pressure and volume together. So pressure and volume are related. That feels very natural, right? So if we give some certain amount of particles, if we give them more space to roam, they're going to hit the walls of the container less, simply because there is more space for them to be in that is not running into the wall, right? However, if you take down that amount of space that your particles are existing in, they run into the walls more often because they're still moving around. They're still moving at the same speed if the temperature is the same. So they're not exerting, or so they're going to exert more pressure because they run into the walls more often. The more collisions, the higher the pressure. So you can see this in the picture here. So when there's lots of space, when there's a full liter of volume for these particles to exist and run around in, the pressure is only at 1 atm. We kind of talked about that before. That's the pressure at sea level, so 1 atm if the volume is 1 liter here. However, if we take that volume down to half a liter, we say that the pressure is raised to 2 atmospheres, okay? So we're seeing that as we're giving the particles less space to spread out from each other in, less space to run around, exist, be, and do, it makes the pressure go up because the more collisions with the walls, the higher the pressure. So the less space the particles have to run around in, the more times they're going to run and hit the walls, of course. So Boyle's law says that pressure and volume are inversely related. So what does that mean? Well, as volume goes up, pressure goes down. So as volume goes up, pressure goes down. And as volume goes down, pressure goes up. So they happen opposite of each other. So that's what an inverse relationship is that these two properties are existing opposite of each other. So if one goes up, the other goes down, and vice versa. And this is assuming that we're keeping the temperature and the number of particles in our sample the same for right now, okay? So when we're using Boyle's law, we have to have a constant temperature and number of particles. But we're going to look at how, therefore, the pressure and the volume change, which is opposite of each other. So we've gone ahead and we have an equation to describe this situation. So we have an equation to describe Boyle's law, which is that the pressure at time 1 times the volume at time 1 equals the pressure at time 2 times the volume at time 2. So this equation represents an inverse relationship. if you want to see how these equations are derived and where they come from, you can find a great explanation in your textbook of that. I'm not going to run through it here in your slides or in this video for any of the equations we have. However, how all of these equations are made, where they came from, why they are what they are, is very well explained in your textbook. So please go check that out if you're interested. However, I'm not asking you to know how to create these laws. I'm asking you to know how to apply them. So what does this P1 V1 equals P2 V2 mean? Well, it's again saying basically that if you change the pressure or volume, something else has to give up, and so that the other half can change. So when we're talking about P1 V1 and we're talking about P2 V2 and we're talking about these like sub 1 times, sub 2 times, for example, like subscript 1, subscript 2, all we're doing is we're thinking about time period 1 versus time period 2. So this might be an initial versus a final. This might be before and after. This might be something and then it changes, so there's something else. So you got to kind of use some of the words that indicate time around these problems. So we're thinking about this as a change, so we're thinking kind of about the time of before and after. So that's kind of how it's working here. These next couple of equations are going to relate time periods. So you got to be careful to know what's happening first and what's happening second. That's what the 1 and 2 kind of represent. One thing I want to mention here is that when you're applying Boyle's law, the units don't matter as long as the units for both pressures are the same. So we're always going to be using pascals, so you're not going to have to worry about that. But you have to make sure that V1 and V2 both have the same unit as well. So V1 and V2 have to have the same unit. So for example, you may have a problem that gives you something like V1 in milliliters and V2 in liters. Well, you're going to have to convert one or the other to make sure that those two units are either both milliliters or both liters, for example. So the units don't matter as long as they're the same for each kind of thing. So whether they're the same for pressure or whether they're the same for volume. So we're going to go ahead and work through 2 examples, and then we'll come back and look at some other laws. So this is going to be a couple of examples about Boyle's law. And so I'll work through these examples for you, but I do want to mention that you do have some practice problems that I'm not going to go through in this video as well. So work through these 2 problems with me, and then go ahead and do those practice problems once you've finished practicing working through them live with me. And let me know if you have any questions, okay? Okay, so let's go ahead and do a practice problem for Boyle's law. So this says if a sample of chlorine gas has an initial volume of 38.7 milliliters and an initial pressure of 102 pascals, and the pressure is increased to 334 pascals, what is the new volume? So as I'm reading this problem, I have to start to kind of look at a couple of different things. So I see the word initial, so I can start to relate that to time 1. I can start to see that I've got some information about increased and new. So I'm thinking a little bit about time period 2. And I want to know what is the new volume. So let's go ahead first and foremost, figure out what we're given, what we need to find, and then we will use Boyle's law to solve this problem. So in this problem, we'll just work through step by step each number down from the start to see what we're given. So if I'm tracing through my problem, I have an initial volume of 38.7 milliliters. So I would say V1 equals 38.7 milliliters. Okay, so I'm always going to write things down like V1 equals N1, P2, T2, something like that, because I want to make sure I'm keeping track of my time. So it's kind of weird in these problems. You've got to make sure you know what happens first, and you got to make sure you know what happens second. So I want to make sure if I'm writing something down like this, that I'm marking it as that V1 time period. I continue on through my problem, and I see that I have an initial pressure of 102 pascals. So I would say that that is P1, initial time period 1. So my initial pressure is 102 pascals. Always make sure you're keeping your units with your numbers as well here. It's extremely important to make sure that you keep your units with your numbers. So always be writing your units. And then if I continue on through my problem, I see, and the pressure is increased to this. So if I see something like increased, changed to, decreased, after, those kinds of words point me to time period 2, okay? So 334 pascals increased, which would be P2. Okay, so that looks like the last piece of information I'm given in my problem, and I want to know what is the new volume. So I'm looking for, I need to find V2. It's a mystery. So in this problem, we're asking for V2, and we're given information about V1, P1, and P2. So if I check this out, I do have a law that relates P1 and V1 to P2 and V2. That's Boyle's law, as we've been talking. So I'll go ahead and write Boyle's law up here at the top. P1, V1 equals P2, V2. Okay? And then from there, I'm going to go ahead and start to substitute some of these values I've written in my given section into my equation. So that's P1 V1 equals P2 V2. My first pressure is 102 pascals. My first volume is 38.7 milliliters. And that equals P2, which is 334 pascals, times V2. Kind of sneaking my V2 in there on the side a little bit, running out of space. But V2 is over here on this side. So in the end, anytime we're solving a problem like this, what we want to do is make sure that we have, we want to get V2 by itself so we can see what it equals. So for multiplying something by V2, we divide by that thing to get rid of it. One thing I want to point out here before we move on is that I kept my units in every single case with my, I kept my units with my numbers. Please, 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 as you are plugging in these problems, if you're writing them down, keep your units with your numbers, because if you're not checking out your units with your numbers, in the end, you may have plugged in something wrong, and that's a huge cue if you get the wrong unit that there's something wrong with your math. So it's going to be a huge help, and it's going to help you cancel units and see what's going on if you put those units when you're plugging in your numbers. So please, please, please be sure that you're doing that, okay? So that being said, to get V2 by itself, V2 is over here on this side. I'm going to go ahead and divide both sides by that 334 pascals. So we'll divide both sides by 334 pascals. And we will divide this side by 344 pascals as well, or 334 pascals, sorry. Okay, so let me just go ahead and I'm going to rewrite this just so we can see it a little bit better. So that means that V2 equals 102 pascals times 38.7 milliliters divided by 334 pascals. So if I'm looking at this problem, now I can kind of see a little bit more clearly what is going on. And what I was mentioning before about the units is this, is now that I can see that I have pascals divided by pascals, so those two units are going to cancel out from each other. So we don't have pascals in our answer anymore. The only thing we're left with in our answer in this case is milliliters. And one way you can triple check your answer, make sure you're on the right track, and you know that you're on the right track, is if you get a unit that makes sense for volume when you're solving for a volume, right? So here, my unit is milliliters. Milliliters represents a volume. I'm on the right track. I'm doing good. I know that I've done the right thing if I end up with volume in a unit that represents volume. I know I would have been really off, and I would have been kind of confused and not on the right track if somehow I had solved this and I got it so that pascals was the only thing that was left. Well, a pascal is not a volume unit. It's a pressure unit. So it doesn't work that way, okay? So V2 here is going to end up in milliliters. Make sure you're plugging in your units so that you can see that unit cancellation. So I'm going to go ahead, type this in my calculator, see what I get.
102 times 38.7 divided by 334 equals, our V2 is going to equal 11.81856 ... However, if I go back to my original problem, I have to make sure that I'm keeping the correct number of significant figures. This number has 3 sig figs, this number has 3 sig figs, this number has 3 sig figs, so my answer should be in 3 sig figs. So I'm going to call that 11.8 milliliters. So 11.8 milliliters there for your volume 2. So 11.8 milliliters. And then I know, or I can go back, I can triple check that I've got the right answer by thinking about a couple of different things. So I triple checked, I'm looking for a new volume, so that's V2. I got an answer that has milliliters, so I'm on the right track, right? Milliliters is a volume unit. And then the other thing I can think about as well is the relationship between pressure and volume to check my answer. So pressure and volume are opposites, right? As you increase pressure, you decrease volume, and as you increase volume, you decrease pressure, okay? So if my pressure is going up, I would expect my volume to go down. My volume goes down from 38.7 to 11.8. Makes sense. So once I kind of get to the end of my problem here, I can think about the relationship with those laws to make sure I've gotten the right answer. And it'll be a huge red flag, for example, when we're thinking about pressure and temperature. If for somehow both your pressure and your volume go up, pressure and volume, I think I said pressure and temperature. Pressure and volume, if both your pressure and volume go up, you got a problem, something's wrong, red flag. So that's how you solve these problems here. I'm going to go ahead, reset, and we'll come back for another example of Boyle's Law.
All right, so we're back for our second example of Boyle's Law here. So this says if a sample of gas has an initial pressure of 722 pascals and volume of 888 milliliters, and the volume is then changed to 0.663 liters, what is the new pressure? So we're going to go ahead, check out what we're given, figure out what we need to find, and start to solve our problem from there. So in this case, we are given, we'll work through the problem from the top. So the first thing we see is initial pressure. So it's 722 pascals. So when I see the word initial, that keys me in that it's like the sub 1 time period, so the first time period. So that means my first pressure, P1, is going to be 722 pascals. And this also is indicating that it has an initial volume. So initial and volume here are together. V1 is going to equal 8.88 88.8 milliliters. I can say the right number. 88.8 milliliters. 88.8. So our initial pressure, 722 pascals. Our initial volume, 88.8 milliliters. And it says the volume is changed to 0.663 liters. So if it's changed, it comes after change. That means it's going to be time period 2. So V sub 2 is going to be equal to 0.663 liters. So, continuing on in my problem, that looks like all of the information that I am initially given. And it's asking me what is the new pressure. So new pressure would be P in the second time period, so P sub 2. So what we need, what we're looking for, need is P sub 2. What does that equal? Okay, so as I'm looking through my problem here, I want to get ready to start to solve. However, there's one really, really big glaring red flag for me right off the bat, okay? And that is this. One of these is in milliliters and one of these is in liters. We know that our volume units have got to match, so we're going to have to convert one way or the other to make them match.
Now, I don't care if you choose to make the liters milliliters or make the milliliters liters. That is a personal choice. It is up to you. Do whichever you feel more comfortable with. Maybe you can always practice converting one to the other, so you have a feel for how to do those conversions. However, I tend to convert liters to milliliters in these cases. I just like the way the numbers work that way better. It kind of takes that pressure of having a decimal off of my back, okay? The other thing I want to mention is that when we're doing these problems, anytime we do a conversion, the significant figures are going to come from the original problem, okay? So even though we converted the number to be able to do some math with it, when I go back to the initial problem, it's the information given in the initial problem that indicates my sig figs. So I'm going to go ahead and convert one of these, and as I mentioned before, I'm going to convert liters to milliliters. So that would be 0.663 liters times, there are 1,000 milliliters for every 1 liter. I've got liters on top, liters on bottom, liters cancels out. I'm left with milliliters. So in this case, I have 663 milliliters as my volume 2. So I'm going to go ahead and I'm going to use this number when I'm doing my math, working through this problem, because now my volume units match, and that matters. So I'm going to erase this, and I'm just going to go ahead and mark that information over here. So that means that V2 is actually 663 milliliters. Okay, so 663 milliliters. All right, so continuing on, now I've got all my units the same. I can go ahead and start to solve my problem. So we have Boyle's law, which says P1 equals V1, P1 times V1 equals P2 times V2. So I can go ahead and plug in the values I'm given and solve for P2. So in this case, we're told that P1 is 722 pascals and V1 is 88.8 milliliters. And we know that we're solving for P2, and our V2 is 663 milliliters. Okay, so 663 milliliters over here. Ran out of space again. I'll get it one of these days. So that being said, I can now start to solve my problem. Again, if I want to get P by itself, P2 by itself, I'm going to have to go ahead and divide by that 663 milliliters. So 663 ml. Divide both sides by that. You got to do it to both sides. So that means that P2 equals 722 pascals times 88.8 milliliters divided by 663 milliliters. So if I go ahead and I take a look at this problem, what I can see is that I can check out my units here. So I have pascals, and then I've got some milliliters. However, this says milliliters on top and milliliters on bottom, so we know those two units cancel each other out, and I am left with pascals by itself as our unit. Does that make sense? Yeah, of course. Pascal is a pressure unit. I'm solving for a pressure. Pascals. Good. I'm on the right track, okay? So that's why we use our variables when we're typing or when we're writing our problem down, okay? That way we can make that check. So P2 is in pascals. That's good. I'm going to go ahead. I'm going to do my math, and I'm going to see what happens. So I have 722 times 88.8 milliliters divided by, or 722 times 88.8, I shouldn't say milliliters, divided by 663. And that's going to leave me with my pressure 2 equals 96.70226 pascals. However, I do have to make sure that my answer is properly written in the proper number of sig figs. So I'm going to go back to my original problem for that. I have 3 sig figs here, 3 sig figs here, 3 sig figs here. Of course, that first 0 doesn't count. So in every case, each of my numbers has 3 significant figures. So I'm going to go ahead and write my answer down that way. So my answer is going to be 96.7 pascals. So 96.7 pascals. And of course, we can go back through, we can triple check that this makes sense, right? So we know that as pressure goes up, volume goes down, and as volume goes up, pressure goes down, right? So in this case, if we look at what volume does, volume goes from 88.8 to 663 milliliters. That's a huge expansion in volume, okay? That's a huge expansion in volume. So we've got a huge change where volume is increasing. So we would expect the pressure to decrease by a lot then, okay? So my pressure goes from 722 pascals to 96.7 pascals. So it went down as the volume went up. So good, we're on the right track there. My answer makes sense. In the end, I've got the correct unit, I've got the correct sig figs, and it follows what I assume should happen with Boyle's Law. We're good to go. So that's all the information I have for Boyle's Law. Please let me know if you have any questions, and make sure you work through those practice problems on your own as well.